Hello guys, here we have a situation whereby we have to compute the pi. So you can approximate pi by using the following series, and pi is equal to 4 times these numbers here. And the question is, write a program that displays the pi value of I is equal to 10,000, 20,000, and until 100,000. So you can see here it's keeping every 10,000. So if you add here, become 30,000 and so forth. So this question is, if you look at it, it might look so challenging because you really have to understand. If you understand, then everything becomes very easy. So we need to create a main method that contains the loop that interacts from this to 10,000 and to 100,000. So instead of what? Instead of 10,000, because that's how it goes here, from 10,000 to 20,000. The difference is 10,000. So I'm going to show you how to write this program. But if we want to test this program by using unit test, then we have to refactor the methods so that we can test the methods. So in this project here, I have this package called YouTube for you. So I'm going to create a class here, and I'm going to call this file name computing pi. Okay, that's a class, and on this class we need a main method, public, or on IntelliJ you can just type main and enter. Then you have autocomplete, which gives you the main method. And I need to create a for loop, and this for loop is going to have int, let's call k, and it's going to be the initial, which is 10,000, and then we are going to say k inclusive. K is less or equal to 100,000, and then we want to the interaction to be k. Let's say k plus equal to 10,000. It's the difference we want to go through. Every interaction have to go through 10,000. Okay. Now we have the loop ready. So inside the loop, I'm going to create a variable called double. I'll explain later. Let me type quickly so I can explain later for you to understand what I'm trying to do here. And this is going to start to 0. Pi is going to be 0, and then I'm going to loop again. This is the inner loop. So here we have outer loop, and here we have inner loop. And this loop, the inner loop, we are going to go int I, and we're going to start. It should be 1, and then we want I inclusively to be less or equal to k, and then I, the interaction has to be by 2. So add plus 2 here. Okay. Yes, here we have to put the semicolon, and then inside this loop we can use the formula, which is pi plus equal to 0.1.d. Then we typecast double 2 times I minus 1. I'll explain this. Bear in mind, just bear with me. I'll just explain. So minus 1.0d over double, and again we take 2 times I plus 1, and then here we add some column. I'll explain this piece of code, and then we have to print sysout system.out.println, and on println I'm going to print the string, this missing t. Println, we're going to put the pi is, and then I want to append by using the plus sign 4d times pi that we have, and then we get the pi. So if I run this program, if all goes well, so we should get this pi with these numbers, which is it's looping from this 10,000 to 100,000 with the interval 10,000 here, and it's performing these calculations. So if I have to explain what is actually happening here, is that the main method contains a loop that interacts through a k of 10,000 to k of 100,000, as I said, in a step of 10,000, and this loop controls the number of interaction and precision of the approximation. You see, so inside the loop, variable pi is initialized to 0 here, and this variable will accumulate the partial sum of the series, and we were given this series here, this one here, and there is an inner loop that we created that interact from I equal to 1 and to I equal to k in step of plus 2 here, and this loop calculates the terms of a series and add them to the pi, as you can see. And then within the inner loop, 2 times calculated 1.0 over double, which is also we multiply by 2 times I minus 1, and another one is this one, which is on the other side, which is 1.0 over double and 2 times 1 plus I. These terms represent the fraction in the Lebesgue. If you Google Lebesgue, let me try it right here. So it's a Lebesgue formula of pi over 4. You see, and then we calculate the terms, and the calculated terms are subtracted by minus from each other, and the result added to pi. And this step alternates the addition and subtraction to approximately or according to the alternative series. So after the inner loop completes, the value of pi multiplied by 4, which is this one here, by 4, then we obtain the approximation of the pi. So, and that's why it's printed here. So, but if you are asked to test this program, which is, it will be much difficult. So what we have to do here, we have to refactor this piece of code here. And what I'm going to do to refactor this software here, this exercise, and I'm going to create another method here out of the main method, and this method is going to be public. It's a static method, and it's going to be type of double, and the method calculate what pi, right? And here I'm going to pass interaction for now, or you can pass anything, but I want to pass the interaction, which is interaction, yeah. So which is going to go through when I call this method, and here I'm going to type the same stuff what I did here. Actually, I could copy it and paste it here. Okay, so the only thing I can change here is that this, I'm going to change this to this one. This k is going to be the number of interaction I want to pass from here. So, and we have problem here because this method is within another method, so we have to cut this and then we paste it under the main method. Okay, and then we have to return something. That's why we have this problem here. So return, and we have to return 4 times pi. Okay, and to remove, instead of this pi here, I can say pi is equal to calculate pi, and then I pass k here. Say pass this k here, and then I delete this because I've already passed on this module here. You see, and then actually we don't need this here. So let's see, and here we have error because of this loop. We have to add the curly braces, which we now can return. So you can see I have refactored this method, and if we run this method now, we should get the same result. Of course, now we're getting some. Why? Because here we are returning this, which is not okay. We have to return this pi as pi. Okay, because the calculation is done here and the method is called here, so we return pi. So let's try again. So now we see we are getting this result. So we need to test to see if this is the correct number. So what I'm going to do is I need to create a test class, and I'm going to type my test on this. Yeah, I can type my test here, and this is going to be test. It's the name of our test. It's the name of our test, and here what I have to start with is I have to create the method which is public. It's not going to return anything, and it's a test as according to the guidelines. We have to start the method test, and then we calculate pi. This is how the method, if you want to test, this is how it's tested. It's written, and then we have to use a notation here at test, and then we have to import this from this package or JUnit Jupyter API. If you don't have it, you can add it on your cloud path or by using tool like Maven. Here I need to create an array, and we create an array, and this array we are going to pass in iterations of array. Should be like this. So we put array and this variable, and then is equal to we put the curly braces. There is two ways of writing array. So this I'm using this for curly braces. So here I'm going to start with 10,000, 20,000, we can go up to 100,000, but I'm going to be going for half, 50,000, and then here we can also have a double of type double array, and we are going to call this is expected values. So how do we get this? The expected value you have to calculate because you have to calculate and make sure that they are correct, so that when you compare, then they will be the same. So I'm going to pass in one more 5. Otherwise, it will be out of bound if they are not the same. What the actual and expected. Okay. Now we need to loop through these numbers. So I'm going to type a for loop, and within the for loop, I'm going to have I is equal to 0. Some column I is less than iteration that we have here, and but we need to cycle the length of it, which is from here to this, and then we want to add by 1, which is plus. Okay. So that's is a for loop we want. So we also say, let's put a parenthesis here, and then we type double actual. This actual, the actual is equal to the name of our class, which is computing pi, which is this one. The name of our class computing pi. Yeah, dot calculate. So it goes like that, and then here we pass iteration, the index of pi, Okay, and then we are set equals, and then here we pass what? We pass expected values and index of array, so we pass I here, and then we also pass the actual. Let's see if I'm right. Yeah, we import from this class, and then here we can have the tolerance. Let's say we add the minimum acceptable error, but for now I'm not going to do that. I just want to try to test this and see if it's going to work. I try to test. Yes, and our test has passed. If we add something like 4 here, definitely our test is not going to pass. So let's see. So we get the error. So it's expected this one, but the actual is this one. So that means we need to add 3 here, and then pass again. Again, I explained to you how this exercise works. It's really complicated, but it's something that if you put your time and you try to understand, you know it's. So thank you guys. It has been a long tutorial, but I hope you learned something. Remember, subscribe and like, and bye bye.